All right, good afternoon and welcome. My name is Abhishek Agrawal and I'm a program manager on the Windows Server and System Center product at Microsoft. I hope you all had a chance to watch the keynote this morning where we showed the new Hyper-V Recovery Manager service. And in this session, we're going to take a deeper look at the new Hyper-V Recovery Manager service and show you how it works with Hyper-V Replica in Windows Server and with Virtual Machine Manager, and allows you to implement enterprise-scale DRs for your data centers and private clouds. So to set the context, we'll use the next hour or so to cover the following things. We will first talk about what are the challenges in today's business continuity and disaster recovery solution space. We'll take a quick tour about the platform capabilities available in Windows Server to implement a DR solution. And then, as promised, we'll take a deep dive look at the new Hyper-V Recovery Manager service. We will have about 10-15 minutes towards the end for Q&A as well. But if you have questions, feel free to interrupt me. We should be able to take a couple of questions in the middle as well. Okay, so take a look at this picture. I found this on a news article on the internet. This was about a coffee shop which was experiencing a power outage, and they had this note out in front of their door, so basically apologizing to their customers that they were not able to offer the best experience because the power was out. Now, the question to all of you, how often would you expect to see this outside, say, a data center that you are managing or, say, a customer is managing? Anyone? Probably not very often, right? You would expect that in today's day and age, this is sort of a solved problem. But turns out that more often than not, even the best of businesses struggle with this basic assumption and get tripped by this assumption. For example, late last year in the month of October, Hurricane Sandy hit the east coast of North America and did quite a bit of damage in its aftermath. Specifically, it took down a bunch of data centers in the New York region. In this example, it took down a service provider called Datagram, and with it, it took down a couple of really popular websites, Huffington Post and BuzzFeed. The reason the data center went down is because obviously the power was out because of the hurricane, but they had their power backup housed in the basement of their building, and the flooding in the Manhattan area caused the power backup to fail as well. But hey, that was a hurricane, and you would expect that in a big hurricane like that, it's possible to have serious outages. But here's another example, though, where a data center in London went down, and in this case, it was just a routine electrical problem, and the faulty UPS system basically caused the data center to be down for about 7 hours. And obviously, all the customers of that data center and the service provider was impacted by this. The point of the slide is as follows, right? No matter in which geography we stay in, we could be impacted by hurricanes in North America or floods in Southeast Asia or good old power outage, right? Any business or any of our data centers need to be able to, handle these events and be able to offer continuous services. But as these examples show, even the best of businesses today are struggling with this assumption and with this problem. They're not able to offer continuous services for their data centers and for their customers who depend on those services. So we double-click on this problem and say, well, what's holding us back today? What are the challenges that is causing us not to be able to enable a good DR strategy in place for all our applications and services? And when we sort of did an analysis of this, few common things came out. First is cost. DR, by definition, is an expensive proposition today. You need to have some sort of a secondary site set up, so you need to have the hardware for it. You today need to buy expensive licenses for replicating your data from one site to another site. And so as an IT administrator, you're in a tough position to make some hard triage calls. You need to choose which of your applications you will actually protect and which of your applications you will actually not protect and let them sort of go down in case of an event. And obviously, that's a hard call. We don't want any IT administrator to be in that situation and make those hard calls. You should be able to provide DR for all your applications that are running in your data center. The second top theme that came out was complexity. Implementing a good disaster recovery solution is a complex problem. It is actually a two-site management problem. You need to configure your settings and software on the primary side. You need to do the same thing on the recovery side. And then you need to basically train your staff so that, in case of a big event, they know what the exact drill they need to follow. And your applications could have real complex dependencies. So you need to be able to model them accurately. And ideally, you want all that modeling to happen in some sort of an automation. But in absence of an automation, today you need to document all those steps correctly and make sure, in case of a real event, you're able to follow that documentation correctly. So as your data centers become more complex, as the number of applications that are running on those data centers increase, obviously the complexity of providing DR for all of that application infrastructure also increases. So that's probably one of the bigger reasons why, as an admin, you again end up saying, okay, the way I'll manage this complexity is by only providing DR for some applications and letting some of these others not have a good story in place. What goes hand in hand with a good DR plan is the ability to monitor your application and infrastructure in a timely manner. There's no point having a good DR strategy if you're not able to execute it on time. And this also ends up, in the current solution space, ends up being a challenge when you don't have a good remote monitoring story and you need to actually physically go into your data centers to do some operations, and which can cost time and as a result can also impact the DR execution of the DR plan that you have in place. So if you sum all of these things up, as I mentioned, what ends up happening is, as IT administrators, you end up saying, okay, the way I will control my cost and the way I'll control my complexity is by only selecting a few my top tier critical applications and only implementing a good DR strategy for that. But hey, you could have other applications running in your data center and you basically leave them on their own devices. And obviously, that's not where we want all of us to be there. We want them to be able to execute DR for your entire data center. So we have been thinking about this problem in Microsoft and saying, okay, if you're building your data center, your private clouds with Microsoft stack, we need to be able to offer some solutions in this space for you. So with that in mind, in 2012, in Windows Server 2012, we invested in a feature called Hyper-V Replica. So it's an in-box replication technology that's available in every Windows Server 2012 and above box, and it allows you to replicate a VM, a Hyper-V VM from one host to another host across a WAN link with nothing else, with no other requirements. So it's inbuilt into Windows Server 2012. We received a great bunch of feedback, very positive feedback on this technology. And in 2012 R2, we have obviously gone ahead and enhanced this technology with a whole bunch of new features that was asked based on the feedback from 2012. For those who are new to Hyper-V Replica, let me spend a few minutes sort of giving a brief overview of this. So as I mentioned, it's an in-box replication technology. So it's available by default in every Windows Server 2012 and Windows Server 2012 R2 machine. You don't need to buy any additional software or any additional licenses to get this technology. And it can replicate a VM from your primary site to a replica site with just a broadband link in between. It's been designed with DR scenarios in mind. So it has features like test failover, where you can basically bring up a replica test VM on the secondary site, perform your DR drills, while leaving your production VMs, not touching your production VMs at all. So there's no downtime that you incur on your production VMs. It's actually application agnostic. So it's actually replicating the entire VM from your one host to the secondary host. So as long as you have virtualized your workload, whether it be SQL or Active Directory or SharePoint, Hyper-V Replica is capable of taking it across from one site to the other site. And the fourth point, which probably is the most important, is actually storage agnostic. So you do not need any special storage on the primary side or the secondary side to make this work. It's a host-based replication technology, so it will work with any storage. In fact, it will work with heterogeneous storage on your primary and secondary side. You do not need symmetric storages. So you could have a direct attached storage on your primary side, you could have SMB on your secondary side, and Hyper-V Replica will be able to make that work easily. And it also supports both standalone hosts, and it also works with the Windows Server cluster. So if you have a cluster running, you have VMs running in a cluster, Hyper-V Replica can replicate it. It can replicate it to a standalone host, or it could replicate to another cluster running on the replica side. So in summary, a really simple technology available in the box, and flexible in terms of how your data center is configured on the primary and secondary side, and lets you do as it offers you a very robust DR platform in the box on which you can start building your DR solutions. We have a dedicated talk on Hyper-V Replica. My colleague Vijay is here. He'll be delivering that. The session is B373. I think it's on a Friday, and I highly recommend this audience to go check this out to understand the nuts and bolts of how Hyper-V Replica works. All right, so we obviously have now a DR platform in the Windows Server platform, but we heard loud and clear from you all that Hyper-V Replica works well for a single host or 5 to 10 hosts and few number of VMs. But if you have implemented a large data center with large number of hosts which are running a large number of VMs, and your data center is dynamic where you're adding new hosts, you're moving your VMs around, you need a DR solution that scales with the needs of your data center. So we listened to that feedback, and with that in mind, in this wave of releases, we are investing in the new Hyper-V Recovery Manager service, which works in conjunction with System Center Virtual Machine Manager and allows you to do DR management for your entire VMM managed data center. So in the next few minutes, we'll go take a deeper look at this new Hyper-V Recovery Manager service. So what is Hyper-V Recovery Manager service? It's an Azure service for performing DR orchestration and management for both protection and recovery of any virtual machine manager-based data center. It offers 4 basic features. It allows you to do real simple at-scale configuration of VM protection. It offers reliable cloud-based recovery plans that allows you to model your application dependencies and automate the failover using a single click for those applications. It offers you a single, consistent user experience to manage and monitor all your DR operations. I'll talk about that in a few minutes as well. And we have thought about the future and built extensibility into the solution from the ground up. If you look at the slide, there's sort of 4 words we use: simple, reliable, consistent user experience, and extensible. We chose these 4 things as sort of the design principles on which we built our service. And I hope as you see the demos and the next few slides, you find that those design principles actually shine through in the design choices that we have made. So you might be wondering, what is this word Azure? Like, we talked about VMM, and I need to protect my VMM data centers, but why is Abhishek talking about Azure? So let me explain to you how we went about designing this service. So let's look at what is a DR problem at its core. So you primarily have a primary data center. Let's assume that data center is in London, and you would be using Windows Server with some storage and networks as your core fabric. And you would be using VMM typically to manage this as the fabric controller to manage this fabric. In VMM 2012 and above, there's a notion of VMM clouds, which allows you to create basically SLA-based clouds on a shared resource pool, and then delegate those clouds to your self-service users. So you would have typically carved out clouds for your tenants and users on this shared capacity pool. So that's on your primary side, and you would typically have a similar setup on your secondary side as well. So if you look at a DR problem, it's basically a cross-site management and configuration problem. You need to configure some settings on the primary side. You then need to go configure some settings on the secondary side. At some point, you need to exchange these settings so that the right infrastructure has line of sight with the other side and can authenticate and talk to each other. And then when you need to protect something, you do the protection on the primary side. But in case of an event where the primary side is going down, you need to then come to the secondary side and then again do some operations. So in a typical software, you basically would design this as a two-screen problem where you were doing some operations on the primary side and then send some operations on the secondary side, which could really be very tedious. So we stepped back and said, well, how can we come up with a better design for this problem? So the way we solve this is by introducing the Hyper-V Recovery Manager. It's basically an Azure service that's sitting in the cloud. It's always on, always available. You install a small piece of software on your VMM servers that registers the VMM server with this service, and the service then orchestrates all your DR management operations. Your data, your actual application and VHD data is always replicating peer-to-peer between your primary site and your secondary site. Let me actually repeat that. Your application data, your VMs and VHDs, are only replicating peer-to-peer between your primary site and your secondary sites. It's only the orchestration and management of DR operations that's happening in the Azure Recovery Services. And you heard Brad talk about the cloud design point. Here's another example of how we are using the cloud design point to design new services for the modern data center. So next, let me go switch to a quick demo and show you how easy it is to actually set up and register your VMM server with this service. So this is the Azure portal. You can go and get an Azure subscription and log into this Azure portal. And the first thing to do to start using the new Hyper-V Recovery Manager is to create what we called a Recovery Manager vault. So the way you do it is you go into the plus new section, you go into data services, and you'll see this recovery services capability over here. And it can let you quickly create a quick vault. You can give it a name. So typically you would give it a name based on the set of data centers that you're managing. So for example, we are in Europe over here, so we'll say it's a Europe vault. Azure will do a quick name check, and you can go and go ahead and create this vault. So what is this vault? A vault is basically an endpoint in the Azure service which will store the relevant metadata and will basically host your orchestration workflows that you will execute on your two sites to manage your DR. So once this vault is created, I already have one created over here. Let me go into that. And it will basically ask you to do a couple of very basic things. You need to basically upload a certificate to this vault. This certificate will be used for authenticating the VMM server. And then it asks you to download a very lightweight agent. It's actually just a 3 MB agent that it is requesting you to install on your VMM server. So I already have a VMM server available here. Let me go run this setup experience and show you how simple it is. It will install the bits. It asks for a proxy server. So in case your VMM is sitting inside a network that is controlled by a proxy, you can configure the proxies which the VMM will use to talk to the Azure endpoint. It asks for the certificate to choose that it will use to authenticate with the service. This has to be the same certificate that we uploaded in the vault earlier. So I'll go and select this one. And now what it's going to do is actually going to connect to the service and find the vaults that are available with this certificate. So it has already found the vault called Contoso Europe, and I'll go ahead and start the registration process. It will ask me to provide a friendly name for this VM server. So we'll say this is my Madrid server, and I'll say register. So in a few minutes, it will actually contact the service and start the registration process. And so while that's going on, let me show what it looks like. So I can click into the resource and then go into the servers. And these are the servers that had registered earlier in the day. So these VMM servers have showed up and are already registered with the Hyper-V Recovery Manager vault. Once I register a server, all the relevant VMM metadata that is needed for management also show up. So I've created some clouds on my two primary and secondary servers. They have already shown up, and now I can start my DR configuration and management steps from here. Okay, so a few points on what we just demoed. So we basically are installing a very small piece of agent software on my VMM server. And this VMM server is essentially registering itself with the Azure service. At all points, we're ensuring that the communication is secure. So it's the agent only makes outbound calls to the Azure service. There's no inbound calls ever made. The traffic is on HTTPS and is encrypted. And we are using certificates to authenticate all the communication that's happening between the agent and the service. And to be clear, at no point are any of the physical hosts on which your VMs and applications are running have any line of sight to the service. The service is not aware of them at all, and we are not installing any software or any agent on any of these hosts. The other thing I wanted to show is if I switch back to the demo for a minute. If you see on the top right corner, I'm actually logged in with my Microsoft domain credentials. So Windows Azure now supports Windows Azure Active Directory, which can authenticate, which can federate with your on-premise AD, and so you can use the same credentials that you use to access your VMM server to log in into the Azure portal and perform DR configuration and management operations. Okay, so I showed you the getting started and setup experience. So you would typically do this on both your primary site and your secondary site. So once you've done that, you're now ready to start, managing the DR across these two sites. The next stage in this in the DR configuration journey is configuration. So we'll talk about how. I'll do a quick demo next of show you how you can use the Hyper-V Recovery Manager to configure the protection for VMM-based clouds. We'll also show you how to do configuration for networks. And then we'll show you how you can very quickly enable protection on each VM. I will show you how it's through VMM, we enable a self-service experience for that. And then we'll go into showing you the recovery plans feature, which lets you orchestrate a multi-VM application level failover. And finally, I'll show you the actual failover operations of planned failover and test failover. All right, so let's talk about configuring protection. So as I talked about, there are a few challenges when you are managing a large data center, right? You could have some clouds with a lot of hosts in them. These hosts could be standalone hosts or clusters, and they could be backed up by different kind of storages. And what you want to do is, define a consistent set of settings that will get applied on these clouds, so that when you actually enable any of the VMs of protection, they all follow the same uniform policy that you configured for the cloud. And you also want to make sure that if your data center is going through a lot of changes, for example, you're adding a new host to your cluster, or you're adding a new host to a cloud, or you're actually moving a VM around in your data center, your DR protection never breaks. So you don't have to go do a lot of manual fix-up if you do any other DR lifecycle operations. And you want to make sure that whatever are the security and compliance policies you apply to the cloud also apply once the VMs fail over automatically to the other side. So we'll show you next how Hyper-V Recovery Manager simplifies some of these challenges for you. Okay, so let's first look at what my two VMM servers look like. So I have what I'm showing you over here is my primary VMM server, and as I mentioned earlier, I've created two clouds. I have a gold cloud, as I'm calling it gold primary, and I have a silver cloud. So I've actually configured them with some storage, with some compute, and with some policies, and actually dedicated that cloud to some of my tenants so that they can start creating VMs in them. So this gold cloud already has some VMs that are already created inside this. And if I look at my other side, so this is my recovery VM. And I've actually created a similar configuration on my recovery VMM. I've dedicated a gold recovery cloud and a silver recovery cloud. The intent of these recovery clouds is that when a VM from the primary side fails over, I want them to show up in the recovery cloud and should follow the policies and the capacity that is allocated for this recovery cloud. So as an admin, you first create your primary cloud. On the primary side, you dedicate a recovery cloud for the primary cloud on the recovery VMM. Once you have done this basic setup, then you can use HRM to then configure protection settings at a cloud level for the primary cloud. So these are the same clouds that are showing up in the Azure portal for me. I see the gold primary and gold recovery. You see that the gold primary is already configured for protection using the gold recovery cloud, but my silver cloud is not marked for protection yet. So let me drill down into this, and it tells me that, hey, I have not configured the protection settings. So I'll click on the Configure tab, and it gives me a bunch of options. So first thing it asks me is, okay, what is the target? To which target site do you want this primary cloud to be protected to? So in this option, I select my Amsterdam VM server. That's my secondary site. Once I select that, it gives me options to which clouds I want to use for protection. So for example, let me choose the gold cloud, and it wants me that, hey, the gold recovery cloud is already serving as the recovery cloud for a different cloud, so that's not a valid option. So I'll go select that recovery cloud for me. So that's not been set up yet, so that option works. And next, I see a bunch of settings related to the actual replication that should apply for VMs that are sitting inside this cloud. So it asks me for things like additional recovery points. So if you're using Hyper-V Replica, Hyper-V Replica allows you to configure more than one recovery point, so you can actually fail over to a different point in time if the need arises. And you can also configure additional app-consistent snapshots for your VMs. So Hyper-V Replica supports both the feature for crash-consistent snapshots and app-consistent snapshots using VSS Writer. Additionally, I can go configure what is the replication method. So I can choose to replicate using the network. So basically, the initial replication of all my VHD data can happen over online. Or if I have large VHDs and I don't have a good enough network bandwidth, then we support an option called offline, where you actually ship your VHDs offline using a courier or something else, and then you import them into VMM on the recovery side, and then the service will detect that and complete the initial replication. And we also allow you to schedule things like the replication start time, etc. So you can actually configure when the replication happens. So what I've done over here is basically at a cloud level specified a bunch of settings that I want all VMs in this environment to adhere to and follow. And I'll just quickly hit the save button, and that's it. With one click, I've configured settings for all the hosts, whether it be standalone hosts or clusters in my cloud, and configured them for protection. Once I've fired off this job, I can go back to my jobs view and monitor the progress of any activity that are done through the Hyper-V Recovery Manager console. So you see the protection configuration job for the Silver primary cloud is in progress. And it'll take a few minutes, so and it will complete itself. So let me actually show you what's happening behind the scenes, because all right, so what we showed you so far is I have a primary cloud, I have a recovery cloud. I want to configure the primary cloud for protection with the recovery cloud. So what's happening when I hit the save button is I will push down a bunch of certificates onto my two sites. These certificates are used by Hyper-V Replica to mutually authenticate the hosts on the two sites. Next, I'll go configure the firewall rules. So this allows Hyper-V Replica to receive traffic from the primary side. And Finally, I'll drop in a bunch of Hyper-V Replica settings onto the hosts. So if any of my primary or secondary have a cluster as part of the cloud, then we will go and automatically install the Hyper-V Replica broker on those clusters and make sure they're also ready for replication. So basically, with that one click, I'm able to do all the configuration management for all the hosts that are allocated to my clouds and ensure that all the VMs in the cloud will have a consistent setting. So you can actually define the SLAs when you're creating your clouds, and you can make sure that all the VMs that are protected in this cloud will follow the same policies and same settings. So one more thing that we do is, at some point, if you ever add a new host to either your primary site or your secondary site, the service is intelligent enough to detect that change, and it will automatically go configure that host with the right set of settings. Similarly, if at some point you were to move a host out of a cloud, we'll make sure that that host gets updated and it's removed from the protection settings related to this cloud. So in short, what we showed you is you can use Hyper-V Recovery Managers and SCVMM's cloud model to do configuration of protection settings cross-site using a single click from a single console. And we work with many number of hosts, any number of settings, heterogeneous configuration, all delivered to you at cloud scale. So very easily you can go and configure your protection. You do not need to go to each host and then do configuration and manually keep fixing things up when your data center topologies change. All right, so what I've done so far is I've actually, all I've done is configuration. I've not actually protected any VMs yet. I've configured my primary cloud and said, you are configured with settings for the recovery cloud so that in case any VM should get placed on this cloud, I want this to replicate automatically to my recovery cloud. So let me show you how easy it is to actually enable protection for any of the VMs in Virtual Machine Manager. And we want this experience to be self-service, right? We want that your application admins, if needed, if you so choose to, should be able to enable replication for their VMs, and as the Fabric admins don't need to be involved in enabling replication for any of these VMs. And we want this feature to work with both VMs and VM templates, so you can actually set the settings up once, and any VMs that get deployed in your cloud should automatically honor that. So we'll switch to a demo and show you how easy that is. So this is my Gold primary cloud. As I mentioned earlier, it's already configured with the Gold recovery cloud. I already have a bunch of VMs, and these VMs are already replicating. But I have this one VM over here, the sales app tier, which has not been enabled for replication. It's disabled yet. So with a single click of this button that's available on the VMM ribbon, I can go ahead and enable recovery. I can enable replication for this VM. So what will happen behind the scenes is actually the VMM service will on the so it's actually a cluster VM, so it needs to be made highly available. But if I had to click that button, what it would have done is actually the VMM would have contacted the Hyper-V Recovery Manager service and said, hey, give me a host on the Replica cloud that matches the settings that I need for this host. So we'll actually use the VMM that's running on the Replica side to find the optimal VM for placement, optimal host for placement, return this host back via the service to VMM, and VMM will start Hyper-V replication between the primary host on which this VM is sitting all the way to the secondary host that we just found. If you were creating a new VM, this setting is already available in the VM properties, so you can actually go and So once the properties page comes up, well, it should come up. Okay. So in the hardware configuration, you see an option called data center recovery, and you can actually go, manage the settings for enabling replication through this property. And you can enable this property on a VM template as well, and basically, enable access to this template to your self-service users. So anytime they create a VM using this template, that VM will automatically be enabled for replication using the right placement policies on the replica side. So once I've protected all my VMs, I can drill down into the cloud, and you see all the VMs will actually show up in my Hyper-V Recovery Manager portal in Azure, and it'll actually show you what the health of these VMs are. So it's telling me that, hey, all of them are replicating from the gold or running on the gold primary side, and they're replicating in a healthy state from the primary to the secondary side. If any of the replication health was to go bad, either go into warning or a critical state, we'll automatically get that notification on this portal, so you can start taking any corrective actions, like checking if the network is down or checking if the storage is running out on the secondary side, and configure that automatically. Right. So to recap this, what we showed is that when you're actually enabling replications, any VM that is getting placed in the cloud will honor the same settings that you configured using cloud configuration earlier, and will use VMM to place the VM optimally both on the primary side if you're creating a new VM that needs protection, or if it's on existing VM, it will make sure it finds the right host with the right capacity on the secondary side, so that in case of a failover, it can boot up correctly. And because this property is enabled on a template, you can basically allocate these templates to your self-service users, and they can use these templates to create DR-enabled VMs without requiring the Fabric admin to come manage each VM one by one. All right, so we talked about configuring the clouds. We talked about how you can enable replication and ensure optimal placement and policy settings for that replication for each VM. The next challenge in configuring your DR for an application is configuring networks. And there's no point actually failing over a VM if you cannot ensure that VM will get connected to the right network on the secondary side, because each VM eventually needs to talk to a bunch of dependent services to be able to continue functioning correctly. And if you have a large number of VMs and large number of VM networks, then manual configuration of these settings can become quite tedious. And ideally, you would want to do all your configurations early and make sure all the settings and application of the settings are managed in an automated fashion, so that you're not actually configuring networks once the failover is happening, because it will increase the time it takes for your applications to become ready for your end users. And networking can be a complex space. You need to manage things like static IP, VLANs, Windows Network Virtualization. And I'm not an expert in networking, so the experience we want to provide is that for a DR admin, the person who's actually setting up a DR, it should be easy enough for him to configure his network settings so that in case of a DR, these properties get managed correctly. So we'll show you how we have simplified that with Hyper-V Recovery Manager. So assume these are my two sites, my primary and my secondary site in London and Amsterdam. And I have two VM networks that are dedicated for different applications. I have one for my marketing application, and I have one for my sales application. So the ask as a DR admin would be that you work with your network administrator and make sure that the right networks are already created ahead of time on your secondary side. So typically, you would make sure that a marketing recovery network is already created and a sales recovery network is already created. So if you have VMs, for example, a marketing VM that's connected to the network marketing, and you would have a sales VM that's connected to the network to the sales network on the primary side. So this is the basic setup that you would have before you come into Hyper-V Recovery Manager to configure your networks. So once you go back into Hyper-V Recovery Manager, you see that under resources we have ability to manage your networks. So I'll select my London site, and it will ask me what is the target site that I want to configure my networks for. So what it has done right now is actually it has discovered all the VM networks that are available on my primary site, that's the London site, and it's telling me if it's mapped to any network on the secondary site or not. So far, I've only mapped one network, my infrastructure network, and I've made sure that, hey, this network corresponds to my infrastructure network on the primary side corresponds to the infrastructure network on the secondary side. So let me go ahead and configure my marketing network. So let me go select map. And it'll show me a bunch of VMs from my secondary site. So for a minute, let me choose the network infra network. And it shows me a bunch of information. So what's telling me is that, hey, on the primary side, your marketing network is allocated to the gold cloud. The gold cloud is configured with the gold recovery cloud on the secondary side. But the network that you chose on the secondary side is not accessible to this gold cloud. So if you go ahead with this configuration, you might see some error scenarios because when a VM fails over, we'll not be able to attach it to the right network because that cloud doesn't have access to it. So I'll go ahead and correct that. I'll go back and select the network marketing VM network. And now it says, yes, it's all good. The network that you're choosing on the primary side is attached to a cloud which is paired to another cloud on recovery, which also has this recovery network attached to it. So I'll go ahead and confirm this. And what it is doing, it will actually map these two networks in our database. So once this mapping exists, anytime we fail over a VM from the primary cloud that is attached to the marketing network on the primary side, our automation will ensure that we attach it to the network recovery network automatically on the secondary host. We'll also make sure that we'll place it on the right host so that the host also has access to that network. So by this very simple mapping logic, we have ensured that when any VMs are failing over, they will automatically get attached to the right network. It's not just during the failover sequence. Even when you are actually enabling replication for a VM that has networks attached, we will make sure that the secondary site, the replica VM also has those networks also created. Now, networks can also change. You can add a new NIC to a VM on the primary site at any point of time. So we detect those changes as well, and we actually the service will replicate those changes to the secondary site as well. So if you attach a new NIC on the primary, we'll go ahead and attach a new NIC on the replica VM and configure it to be attached to the right network automatically. So basically, what we showed is we mapped my network marketing to my recovery marketing network. And once that is done, anytime I enable replication for a VM, we will ensure that that VM automatically gets connected to the right network. It gets placed on the right host, and any network changes that's happening is replicated across automatically. So here's a quick recap. We will place the host, obviously, and be able to map use the correct networks. If you had static IP pools configured with the recovery network, and if your VM was using a static IP, we will ensure that the replica VM also gets a static IP once the failover happens. All right, so we talked about configuration so far. So all we have done so far is configured my cloud protection policies. I've enabled replication for some VMs, and I've configured the network correctly, right? So this is the steady state. We want to be in this state for as long as possible. Like hopefully forever, we'd never have to actually ever, do a recovery operation. But the core feature of a DR product is recovery. You actually want, in the case of a big event, you want to be able to recover your applications very quickly. And ideally, you would want a single-click experience to be able to bring up your applications quickly on the secondary side. But as we mentioned, there's some challenges that exist in doing that today. Your applications could have complex dependencies, right? You could have a 3-tier or a multi-tier app, and you want to sequence the failover of these VMs in the correct order. Otherwise, your applications might not boot up. And you might have a lot of customizations needed for your app that are specific to your applications. You might need to change the configuration of an application. You might need to change the DNS settings, a whole bunch of customizations. So you need the ability that you're able to customize your recovery flow with scripts. And there might be scenarios where you can't automate everything. You might actually need to have somebody physically go in to the data center and do an operation. Or you might need to wait for an approval before you go ahead with some of these. So we'll show you next how you can use the recovery plan feature in Hyper-V Recovery Manager to simplify and automate some of these steps. Okay, so I have already created a recovery plan called the marketing recovery plan. Let me drill down into it. So you see there's few groups that I've created. The first thing that my recovery plan does is actually shut down the VMs on the primary side. The reason we shut it down is in case there was a false alarm or a false, say a network break, you don't want to end up in a split brain scenario where both the VMs on the primary and secondary are running. So it's advisable that you shut down all the VMs before you attempt a failover operation. The first group that I have is my AD infrastructure VM. So I have a VM that is running AD, and what this group is telling me is, hey, before you fail over any other VMs, make sure this AD VM is failover, because that's the core infrastructure VM, and without that VM, my applications will not come up correctly. In the next group, I have my SQL database, so that's my backend store. And again, this needs to come up before my front ends come up so that my application boots up correctly. And in the next two groups, I have my middle tier and my front ends. So that's what I've done. I've basically used the feature of groups in recovery plans to sequence how I want the failover to happen. And what the recovery plan guarantee is that these operations are always executed in order. We'll never go out of order because of the groupings that you have specified. So let me go back here, and what you see at the bottom is a couple of options that are available to me. I can do a planned failover, or I can do an unplanned failover. Typically, you would choose planned failover if you were doing some sort of a planned maintenance on your primary site, or you had a disaster avoidance scenario where you knew a hurricane was coming, or you knew some event was approaching. So you could plan your migration ahead of time and say, we'll take a planned downtime. Sorry, not a downtime, but I'll do a planned failover and bring up my VMs at the other end. And the other gesture is the unplanned failover, and you typically use that in case of a real disaster, right? So what I'll do right now is I'll go ahead and fire off the planned failover workflow. And it will confirm a couple of things for me. It's saying, hey, we're going to fail over from the London site to the Amsterdam site. And it's asking me that, do you want to reverse replicate once the failover completes? So the idea over here would be that, hey, because this is a planned downtime, I will fail over my VMs to the secondary site. But then once they come up over there, I want them to remain protected, and they'll start replicating back to the London site so that I don't lose any data once I come back to the London site. So I'll go ahead and confirm that. And this will also go kick off a job in the background, which I can use the jobs view to monitor with. So this will take a few minutes to run because, as I mentioned, it's going to do a bunch of shutdowns on the primary side and then bring up the VMs in order on the secondary side. So it'll take an order of minute or two for each VM, and we have 6 VMs, so it'll take a few minutes. I'll take this time to also talk about the difference between doing planned failover and unplanned failover from the way we have implemented it. In planned failover, we'll ensure that each of these operations actually work correctly. So if there's any error in doing a planned failover, we treat that as a hard error. So we'll actually stop your planned failover workflow so you can actually go back and correct whatever is causing the failure and restart that workflow. But in case of an unplanned failover, it's sort of an emergency situation. So we'll do a best effort. So you will attempt to do all the operations, but if any operation fails, we'll not stop the workflow and we'll attempt to basically finish as much as we can so that you're able to recover as much of your applications at the other end and then fix up as needed. So that's the difference between doing a planned failover and an unplanned failover. So while that workflow is running, let me show you how easy it is to create one of these workflows. So go back into recovery plans and say create. So I already have the marketing recovery plan, so I'll go to create a sales recovery plan. And I'll specify the source to be from London to Amsterdam. And next, it will go, filter out the VMs that I want to select. Because I've already protected my marketing VMs, I'll go ahead and select my sales VM and confirm that. And it'll take a few minutes and go ahead and create this recovery plan for me. So once this recovery plan comes up, I will be able to actually go ahead and customize this as well. So right now it has put both the VMs in the same group. Obviously don't want them to come up together, so I'll go ahead and sequence them correctly. The way I'll do it, I'll create a new group. So I've created group 2, and then with a single click, I can move this VM down to the second group. And then I want some scripts to run after the SQL DB fails over. So I can quickly go ahead and add a script. And I want that script to run after the failover of that. And I'll say the script is update my DNS. And I'll specify the path to the script. So the way the path works is it has to be a script that's sitting on your VMM library server. So as long as that script is available, we'll go ahead and... So this could be a PowerShell script that is you have written already and that's sitting on your library server. And and I can go ahead and specify that as part of my recovery plans. But it's possible that, there's some operations that we have not automated correctly and we might need to do some manual actions. So that facility is also available in the recovery plan. So I can say, hey, before I run any of this, I want to, turn on the air conditioning, right? And I can specify additional instructions for my IT admin on the secondary side. And I can also specify when this manual action should be taken. Like, should I take it on a planned failover, test failover, or all the time? So I'll go ahead and save that. And finally save this recovery plan. Okay, so this recovery plan will get saved, and now I have a recovery plan with a custom script and a manual action specified in it, and then I can go ahead and perform the same failover operations that I showed you earlier on the sales recovery plan. Okay. Just refresh the browser and make sure get a new session. Okay, so while that comes over, let me switch back to the slides. So what we showed is, by using very simple notion of a recovery plan, we let you organize application dependencies and give you basically a one-click failover button. So as long as you model your application dependencies correctly, you can add your custom scripts, you can add your manual actions, and with a single click, fail over your applications when needed. So to quickly summarize, we take care of shutting down of VMs on the primary side. We allow you to sequence using groups the dependencies of VMs that are there in your application, and you can extend your orchestration with your own custom scripts and or manual actions so that you can do the right thing in case when your disaster strikes, either for the planned failover or for an unplanned failover. Okay, so we talked about the need of planned and unplanned failover, but most of the time you will be spending, if you're using a DR product, you'll be doing what is known as DR drills, right? So DR drills basically are needed for compliance reasons, and you need to basically be able to train your staff ahead of the big event so that they know exactly what steps to follow to be able to bring up the applications correctly on the second time. And when you're doing a DR drill, you do not actually want to impact any of your production workloads or anything that's running on your production side. And you want the DR operations that you simulate to follow the real failover as closely that is possible. And finally, you want a consistent experience while you're delivering this, while you're doing DR drills. You do not want when your staff moves from doing DR from a test failover to the real thing, the change in experience confuses them and they end up making errors. So we'll again go back to the demo and show you how you can use the recovery manager to quickly do DR drills. Okay. Okay. All right, so I'll go back to my marketing app recovery plan. And for a minute, let's go back and check how the planned failover that we triggered is progressing. So I go back into my JAWS view and see it's still in progress. It's still failing over those VMs. So we will go back to the new recovery plan that we just created, the sales recovery plan, and trigger a test failover on it. And what test failover is going to ask me is, specify a logical network in VMM at the secondary site. Why do we need this logical network? So we'll basically, when we bring up the test failover VMs, we do not want those VMs to ever connect to the production networks, because if they do, they will actually create a split brain and cause your production applications to not work correctly. So the way what we want is these test VMs to come up in an isolated network, and for that we require a logical network to be specified. So ideally, you should have configured a logical network ahead of time in VMM. And once I confirm that, then I'll start triggering off the test failover workflow. And the test failover workflow will execute the exact same steps that I've configured in my recovery plan. So it will go execute my script. It will go, wait for my manual action, and will go through it step by step. So let me actually show you what's happening behind the scenes when I do a DR drill. This was the configuration that we showed you earlier. And let's assume that you're using Windows Network Virtualization on your Replica side. So when I basically kick off a test failover, what I will do is I'll first use the logical network that you specified to create a copy of the network using Windows Virtualization. And once that network is created, I will create a test replica VM and ensure that VM is attached to the correct network. So once that environment comes up, you can then run your test suites to ensure that your application is functioning correctly. And once your verification is complete, you can come back to the service and say, "Yep, I've verified my DR drill is good," and then we'll go ahead and clean up the environment and take you back to the clean state that you were in. And all of this is fully automated, so you do not need to do any of the steps manually. We will go create the test networks. We will ensure that the test VMs are connected to it. We'll allow you to verify that all of that is your application is functioning correctly. Validate your DR drills, and then come back. If once you're done, we'll clean up the environment and not consume any resources. So, few things that we take care of when we are doing these DR drills. We will take care of creation of the networks. The test VMs will come up on the exact same network, will come up on the same host that the replica host was setting. So this will ensure that if there's any issues with the host, you can use the DR drills to verify that your hosts on the replica side are working correctly. While you're doing a test failover, at no point you touch your production VMs. There's no impact to that, so your production VMs can keep continuing to run as is. And as I showed you, the user experience is exactly the same in the Azure portal. It's just a next button to your planned failover. So the same experience that you use for creating a recovery plan, monitoring the progress of the recovery plan, and doing a planned failover, you can use the same experience to do a test failover. So your IT staff can be fully trained when, in case a real event happens and they need to do a planned or an unplanned failover. All right, so I'll sort of begin wrapping up now, but there was one thing that we wanted to highlight. So let me do a quick check. How many of you have 2 or more data centers that you're managing today? Okay, anybody has like 3 or 4 data centers? Wow, good. Do drop your business cards. We want to make sure you come and join our preview programs. So if you were to think about the solution that we showed you earlier, right? If you have more than 5 or more than 2, 3 or 4 or 5 data centers, if you were using a peer-to-peer way of managing your protection and your DR strategy, you would have to do a lot of site-to-site configurations. It doesn't scale with the number of data centers that you have. But the design that we have shown, if you add a new data center into the picture, it's as easy as registering a new VMM server. So as long as you register each site with the Hyper-V Replica manager, you can now manage DR between any 2 sites. Your site A could go to site B, B could go to C, and C could go to A. And and this could be 3. Tomorrow you could add more data centers. So based on how your enterprise data center scales, this solution scales with that and allows you to manage multi-site DR very easily. So again, as we mentioned, this is a unique design point that we have chosen, the cloud design point, and you will see in future more and more services sort of take a leaf out of this design point. Okay, so Hyper-V Replica Manager, obviously we said it works with System Center Virtual Machine Manager and Windows Server, but today we are announcing that it works with both VMM 2012 SP1 and the new VMM 2012 R2, and it supports both VMM Server 2012 and the newly announced VMM Server 2012 R2 previews. And as these previews go to RTM, we will enhance the service to support the RTM versions of these builds as well. So we are ensuring that you do not need to have the latest and greatest bits. If you're using VMM SP1 today, if you're using 2012, you can go use the Hyper-V Recovery Manager with this service and start using it for managing the DR for your data centers. So that's all I had in terms of content. We have about 10 minutes left, and so I'll open the floor up for questions and answers.
Servers are correctly configured.
Correct.
Yes. What happens if I mess up my Hyper-V Replica configuration on a Hyper-V server?
Okay, so the question is, we showed that the agent that we have when we do the cloud configuration manages the configuration of the Hyper-V on the host. So we have some intelligence built in that if you're changing the settings of any of the hosts, if you reconfigure the cloud, we will actually go and reset the settings back so you can go back to a clean state.
But I have to manually reconfigure it.
So in the current version of the service, you have to manually reconfigure again. We have a feature in the backlog where we are considering auto-detecting any settings change and fixing it on the fly as well.
Does it handle guest VMs that are
Okay, so the question is, does Hyper-V Replica work with guest clustered VMs? The answer that today it does not work with guest clustered VMs.
Is there a way to host the Hyper-V Recovery Manager in-house?
So the question is there a way to host the Hyper-V Recovery Manager in-house? No, today you cannot. It is an Azure service, and but it's only a management and orchestration service. Your replication is only going site to site at all the time.
You can have your Azure, the corporate Azure, what they told in the key session.
So your actual VM data, your VHD data is only replicating between your two data centers, site to site. Only the metadata about the VMs and clouds are coming to the service. We're only doing orchestration. There's no actual VM or VHD data ever going to Azure at any point of time. So the question is pulling Hyper-V Recovery Manager in-house on the roadmap? Not currently. As I mentioned, there's specific reasons why we chose that design point. Like if you have two sites to manage, this design point makes it really, really easy. If you were to go in-house, then you would be limited to only a single site management or managing, say, within one building to another building. So currently, it's not on the roadmap.
What about guests with multiple NICs?
Yes, we support guests with multiple NICs.
You also showed that in VMM setting for a virtual machine, you could check the replication, the new setting,
Right.
and even in the templates.
Right.
Is that after you install the agent, or is it there all the time?
No, it's available only after you install the agent.
Okay.
Okay.
So you can't configure it until you have.
You cannot configure it until you have that agent.
What's the charging structure of this?
Pardon?
The charging structure?
So the question is, what is the cost? What's the cost of charging structure? So currently the service is in preview. We haven't finalized or announced any of the costing or the cost of the service right now. Again, we have not announced the cost or the plan for the service yet. Yes, sir.
How often the VMs get replicated?
How?
How often the VMs get replicated to rotation?
Okay, so the question is, how often do the VMs get replicated from primary to secondary site? Hyper-V Replica in 2012 replicates at every 5 minutes. In 2012 R2, it has gone to a customizable replication frequency, so you can configure to 30 seconds to all the way to 15 seconds. If you're interested more in the Hyper-V Replica settings, as I said, session 373 will have more details on that as well.
Is there a plan to go for synchronous replication for replicas?
Great question. So the question is there a plan to go for synchronous replication? As I mentioned in 2012 R2, we have gone to what we call a near sync feature. It goes down to about 30 seconds, replicating every 30 seconds. But we are aware that there are some application scenarios where you need to have sync replication. So if I was to go back to the slide. So one of the design points that we have put in place is that the replication channel can be extensible. So we do not have, currently we use Hyper-V Replica, but tomorrow there are possibilities where we can use, if there were other sync channels available for replication, we could use that. But today we use Hyper-V Replica only. Yes, sir. Can you repeat?
Migrating from Hyper-V 2008 to 2012, a whole clustered environment. Have there been problems?
I think it's possible, but I do not know that on the top of my head. You can come down to the booth, Sovereign Cloud Tools booth. We'll find some expert to answer that question for you.
What was the question?
Okay, sorry. So the question was, is it possible to migrate 2008 R2 Hyper-V VMs to 2012? And are there any known issues? My understanding it should be possible, but I'm not the expert on it. If you come to the cloud tools, okay. Okay, so I think it's possible, yes. Yes, sir.
The service not for the other.
Other OS like Unix, Linux, I mean, or this is only Windows-based solution?
Okay. So Hyper-V replicas, so we support base for Hyper-V, so as long as it's a Hyper-V VM, we will work. Yeah. And in 2012 R2, there's been enhanced support for Linux VMs as well.
Is it also possible to store the PowerShell scripts which you are using in your recovery plan in Azure instead of in your VMM library?
No, currently you require your scripts to be stored in your VMM library as well. If you can, we can talk offline if there are scenarios where you need the scripts to be uploaded, we can consider that. But currently we keep all the data on-prem only. Only the orchestration gets kicked off from the service.
Does Microsoft support replicating SQL 2012 always on VMs?
So the question is, does Hyper-V Replica work with SQL 2012 always on VMs? So if you're using SQL always on, then the intent was that you would be using SQL to replicate that data. Hyper-V Replica complements SQL replication. So for example, if you had a 3-tier application, what you could do is, let your SQL tier get replicated using SQL always on, but use Hyper-V Replica to replicate your front end or your web tier, which might be stateless and might be easier to replicate. So it's possible, but if you, as I mentioned, it would be preferred that if you're already using SQL always on, then you use that for your app level DR, and then you use Hyper-V in conjunction for other tiers that you want to replicate. It wouldn't make sense to replicate the same data twice, once with SQL always on and once with Hyper-V. Okay, any other questions? All right, so that's the summary, and as I mentioned, the service is available in a preview right now. So if you go to this link on Windows Azure, it will allow you to sign up for the Recovery Manager, to the Recovery Services service, and starting next week, we'll be refreshing a service on Azure Portal as well to enable support for Windows 2012 R2 and VMM 2012 R2. And so I highly recommend you guys to sign up for the preview, give it a try out, and give us feedback so we can improve it and get it ready for GA for you guys. All right, so that's all I had. Really thank you for your time and to listening to and for your good questions. Here's some related contents, as I mentioned. You should check out 373 to learn more about Hyper-V Replica. There's a session on what's new in VMM 2012. It talks about the private cloud and the VMM cloud scenarios in session 357. And I will be available in the cloud and data center booth in the expo. So feel free to stop by if you have additional questions. So here's some resources you can go check out, and I'll request all of you guys to take some time and fill out the evaluations. It helps us sort of tune our content based on what you needed. Thank you all. I'm really humbled for your time and your interest. Thank you.